Every day you take a sip of water, trusting its quality without realizing it may be contaminated. According to UNICEF, a quarter of the world's population lives in homes without safe drinking water. This silent danger often jeopardizes health and can steal lives. You deserve to know the quality of your water for yourself. That is why we built SensiCup. A smart cup that gives instant feedback about the cleanliness of your water using sensor data and machine learning.
Hi, my name is Neha. I am a rising freshman at the University of Maryland studying civil engineering, and I will be a CAD designer for this project.
I'm Sam Baxter. I'm a dual enrolled student doing the early college program, enrolled in Damascus High School and Montgomery College for computer science. And I plan to come here at USG to study cyber-physical systems engineering. And I am the hardware and software engineer.
Hi, my name is Kubra, and I am an early college student, rising senior, and I am the team lead.
Hi, my name is Stephanie. I'm a rising senior at Thomas Wooten High School, and I will be the software engineer for this team.
Hi, my name is Jasmine Algama. I'm a rising junior at Winston Churchill High School. I'm the hardware and electronics engineer.
We are Team SensiCup. So most people don't know how harmful their water is until after they've consumed it and gotten sick. And usually to test this water, you have to send it to labs or bring in multiple kits and just do multiple testing, which takes a while. So I want to come up with like a practical solution that could kind of show the user immediately how clean the water is.
So what we considered is the SensiCup. You fill the SensiCup up, any sample of water, and the purpose of the project is to relay that information to an app so that you can get the exact values of, for example, the total amount of dissolved solids, the pH of the water, and just generally the contaminants that are causing you to have that big headache or causing your throat to hurt.
So in terms of hardware, I think the wiring will be a little bit tricky. It's really compact, it's really tiny, and you need like really steady hands, and you're going to need like pinpoint accuracy while wiring.
Something else that's going to be pretty tough is going to be manually training the AI to recognize the undissolved materials that are going to be in the water. We're going to have to manually take pictures of samples and add contaminants ourselves so that we can train the AI. So manually training is going to take a while.
So in the beginning of the week, we tried to configure the OpenMV camera, the small little camera, to work on the website, but we found out that it wasn't compatible with the machine learning algorithm that we needed to detect microplastics and undissolved solids in the water. So we switched to a temporary webcam that we're going to be using for the time being. And so we programmed that camera to be embedded to a website that they created.
So with this website that we kind of made, you can enter your cup code.
And based off of the different levels like pH, TDS, and then also salinity, it will tell you like your water is excellent and you can drink it. And then also here we plan to implement, again, machine learning to kind of identify any particles in the water.
And then we want to implement the live machine learning webcam onto the website, because right now it's just a live camera feed without any detection. So we plan next week to have that detection, and hopefully by next week our sensors will come in and we'll be able to actually configure those and set those up on the website. We found an existing database with magnified contaminated water on the internet. There were around almost 2,500 images on it. So we imported that into our machine learning algorithm. And then once our parts finally came, we pivoted from the existing database to taking our own pictures that will be closer to what SensiCup actually sees.
So me and Sam actually were taking pictures with the camera that we finally received, and then it has a 100 times magnification lens. We tried with a lot of control. So there's a control, which is like just like normal drinking water, and there's dirt water, pond water. We try to find any type of water that we can use.
So you can see all the different specks and pieces of dirt in the water. This is what we've been taking pictures of, and this is what we'll be annotating. We'll be drawing boxes around the solids in there, and then we'll be labeling them, and that'll be used to train our machine learning. And then next week, I think another big goal is to solidify the data transfer method from the readings from the sensors onto the website, or at the very least onto the computer that the website is hosted onto.
So far right now, we have added a base to our pitcher. Basically, it's a clasping mechanism. We can take it out, and we'll have to store all of our electronics and our sensors. So far, it's been pretty promising. I think the next base that I am going to 3D print is going to be even better.
So basically, we got our TDS sensor to actually wirelessly show the values on our web app. So through the ESP32, now we're trying to
incorporate other sensors like our pH sensor
Exactly.
into
Our pH and our temperature and TDS, we're trying to use that same method to send all of the data that is combined to the web app. So sending that wirelessly over to the web app is going to be our biggest challenge right now. We're shifting from an AI model to look at the images to detect what's in there, because it's proven to be pretty impractical. We're shifting to an AI algorithm, taking all the parameters and all the sensor data and creating a cleanliness score on a scale of 1 to 100. So we're gonna put the sensors into the bottom of the cup. We're gonna fill in any cracks or holes that might allow water to seep through. And then we're gonna put epoxy resin around the perimeter of it so that we seal it. And then from there, we're gonna put all the electronics and organize them inside of the base. And then I think that'll be about it.
I'm proud of us. I think we did the best we could. I mean, this is just a prototype, so we should all keep that in mind. But it's functioning. It has all the mandatory sensors, the live camera feed, and our web app. So I think we're pretty satisfied.
I think we have a very special chemistry when it comes to our team. I think we all work together very, very well. We click, we build and bounce off each other very well. And in terms of the actual product, I think it's just such a ubiquitous like product that everybody can use. The applications are endless. As long as you have water, as long as you have a suspected problem, you don't even have to have a problem, you can just suspect it. You can always use SensiCup. And I think that sets us apart from all other teams.
Good evening, everyone. Have you ever questioned the quality of your water? Well, we've created a smart device that instantly checks it so you can drink your water feeling at ease anywhere, anytime. Welcome to SensiCup, a health check for your water.
SensiCup uses a wide range of sensors, each programmed to expose the secrets in your water. Our sensors detect the salinity, the temperature, the TDS, and also the pH system. We also developed an AI algorithm that compiles our sensor data to create a personalized safety report displayed on our web app with a live camera stream.
We currently have a working SensiCup model featuring a 3D printed base that holds all our sensors together, along with the web app featuring the sensor data to basically detect your overall water quality. We want to compact our design into a smaller cup and even expand to a mobile app so that SensiCup is globally available for everyone in the future. And when I mean everyone, I mean we want everyone to benefit from SensiCup's smart and innovative technology. So we were able to detect this much about your water in only 5 weeks. Now imagine how much we can actually detect in 5 years.
Thank you, and we are
SensiCup, a health check for your water.